All right, everybody. So because I couldn't be in class today, I wanted to go over the slides with you. If you need to kind of hear and listen a little bit more, other than reading the slides themselves, which I'm also going to post on Carmen shortly after I upload this video. But this lecture really talks about developing early number concepts and number sense in children. I'm going to share with you a couple of resources that you can use for your classrooms and working with students of your own. And we'll talk a little bit about these ideas behind how children develop, thinking about and understanding number concepts. So a little bit of housekeeping. I wanted to let everyone know that Go React installation is going to happen this week. You'll receive an email from Go React once the account's set up and prompting you to pay the registration fee and then activate your account so you can start uploading videos. These are going to be used for our rehearsal teach as well as our student interview. And I'll talk a little bit about that once I get back from my trip and how we're going to go about facilitating it. But over the next couple of weeks, get yourselves acclimated, get the account set up once you receive that email, and I'll also send an email out saying that account's been activated. So one of the things that we didn't really get to do because of weather, because of timing, and because of the schedule is go on our community walk. But I wanted to just really quickly talk about how we can actually use areas that we're familiar with, areas within our community, close by our schools, our field placements, to generate mathematics problems for children. So these are a couple of pictures just from local gardens and local sites close to campus in the immediate area. And these are a couple of problems that you can take and lift out of these images. So this could be things like looking at the price of food for farmers market. Given that prices for each item produced are different dollar amounts. You can ask students if they have $100 in expenses for seeds, what are different ways to go about spending that $100? And you would notice that there's a bunch of different ways to solve this problem, so there's a lot of different ways to access. Contrasting this, you can look at things like area for these flower beds. So if given a certain dimension, you can talk about how much space is needed to plant. You can think about things like harvesting and how much time it'll take for a plant to yield crops. You can think about number of plants that are produced in a specific potter, or given that there are 7 slots and in a number of trays, and you can use this to get at early addition, multiplication, counting, and division strategies in children. So I wanted to just point out that it's not just about pulling problems out of our books, but we can use things around us as a source of inspiration for generating problems. And then here's just another one that we had thought about: strawberries. So strawberry plants yield around 250 grams per season. The median weight is 10 grams. If we have 14 strawberry plants, how many strawberries do we estimate are produced this year? So again, this is this idea of estimation. It's this idea of multiplication, of addition, and just lots of different ways to engage students in thinking about early mathematical concepts. So with respect to the Twitter chat, in particular, Brooke, Nicole, and Justin will have you all present when I get back and kind of fill us in. I might have Dr. Chow facilitate that. He'll be here next week. So start thinking about those questions, compiling that information, and synthesizing what we extracted from the tasks. I went over this before a little bit, but I just wanted to reiterate the rehearsal teachers coming up. We're going to have our first group present their lesson the weeks that I get back on early number concept. And again, this is split up into 4 different parts: the plan, the rehearse, the reflect, and the present. In terms of the planning, you've all selected one of the 8 different content topics, and your task is to find a relevant task in Vanderwall, in Teaching Children Mathematics Postscripts, archives of which are available on Carmen, the Elementary Teacher's Book, Dan Meyer's 3-act tasks. All of these are resources on Carmen, but find an activity that you'd like to try to facilitate. Email me your lesson plan that you're thinking about with alignment to standards. And in these activities, I want you to go to the readings and pick out and predict at least 3 strategies that you think might come up as individuals are solving these problems. Let me know what kind of materials you need: slides, manipulatives, etc. And I want to make sure that the planning's done collaboratively. Everyone in the group has a role in terms of talking, in selecting strategies, and in talking through each other's thinking. For the rehearse itself, the structure is going to be a 20-minute co-teach. The idea, if we can get actual students to come in, I'm working on getting that. It might just be us. We might have a group of students, if that's ideal. But it would be working with students on implementing these tasks. And each group needs to select a volunteer from the class to video your rehearsal teach, so we can upload this onto Go React. In terms of the reflection, the revision, and the create, you're going to actually, what you're going to do is you're going to replicate that teaching observation using the 4 lenses that we did looking at the video on bean pods. So each one of your group members will select 1 or 2 lenses, that of learning, teaching, power, and participation of the task, and analyze your use of teaching moves and your purposes behind those. Look at these lenses, document what you notice on Go React, and the goal here is that we'll improve our student engagement and student learning by looking at and analyzing what decisions we made and how we might improve those in the future. And then after that, 2 weeks after, you're going to engage in a 10-minute short presentation on your final lesson. You're going to talk about what you learned through the rehearsal teach and your feedback, and you're going to share the artifacts that you created, and we can put them online, and that way we have access to building a repository of those tasks that we can take back into our own classrooms and share them out. So I'm still thinking about the medium that I'm going to use. We could do Dropbox, we could do Buckeye Box. Ideally, we want something not affiliated with OSU so it won't go away. So again, we'll talk a lot more in detail about this as the weeks come up, but I just wanted to make sure that we kind of understand all of the different components of this rehearsal teach. And again, the case study project, which is coming up as well, I've started to communicate with the cooperating 3rd grade teachers at GEMS. And again, we cut the community walk because of weather, but we're going to get in and have our first get to know you interview the week or so after I get back. You're going to talk to the child about their background, their interests. You'll facilitate then 3 problem-solving interviews in class each of those weeks sequentially, where you'll give them a task, ask them to solve it, and you'll capture their strategy in less than 2 minutes. And then after the 3rd interview, you're going to write a letter to the parent and a report for cooperating teachers and me to learn about their mathematical thinking. What did you learn? What did you understand? In terms of the getting to know you interview, and again, I'll go over this again, what that looks like is it'll just be a short 1-page write-up, and that's actually going to be the first page of your final report. So you want to introduce your student, not using their real name, but using either only their first name or a pseudonym. Talk to us about what you noticed about the student, and think about what connections you might use with respect to the mathematics teaching, and help us understand what it's like to do math as your student. So these are questions that you're going to want to ask them and synthesize as you're going through the problem-solving interview process. If you have any questions about this, you can just send me an email, and I'm happy to answer. So again, the short talk I have planned for today is really going to look at exploring early childhood mathematics, and it's going to be digging into those readings and lifting up some of the concepts that we talked about and that we've learned about. So what we know from the readings is that there are a lot of different strategies that children use for counting, adding, and subtracting, and they can get very complex. So think about those activities from Chapter 8 in Vanderwall, and think about how you might use those activities to get students to explain their thinking. And again, the Vanderwall book is a great source of tasks that you could use for your rehearsal teaches. So think about these questions as you're kind of processing this talk. So the first major concept that was embedded in the readings is this idea of subitizing. So what is subitizing? The definition of subitizing is really just being able to quickly and efficiently recognize a quantity without having to count it. So you can see something like 5 and recognize that it's 5. You can see 2 and you can recognize that it's 2 without necessarily counting. Without counting. It's just recognizing it visually. What's important to notice and understand about subitizing is that the configuration and the layout of the objects makes a difference in whether children are sometimes able to subitize. So if you have 5 objects that are arranged like the side of a 6-sided dice, that's sometimes easier for children to recognize as being 5 than, say, a straight line of 5. So subitizing happens based off of recognizing patterns and configurations of numbers, being able to see and know the quantity, okay? In terms of early counting, There are three ways that we kind of think about this along with subitizing. So one is this understanding of a number sequence, and that's just the names and ordered list of number words. So like 1, 2, 3, 4, 5 is a sequence of numbers. One-to-one correspondence is this idea of linking those words in the number sequence to an explicit object. So number sequence is just being able to count. Like my young children can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They can count, but there's a difference in understanding that 1 corresponds to an object, 2 corresponds to another object, 3 to another, 4 to another, 5, etc., etc. Cardinality is this big idea of understanding that the last number that you say when you're counting is actually how many that there are. So you'll see in some young children, they will count a set of objects, 1, 2, 3, 4, 5, 6, 7, 8. You'll ask how many there are, and they'll say 5. So that would be the child doesn't have a concrete understanding of cardinality. They understand one-to-one correspondence, they understand the number sequence, but cardinality is this idea of recognizing that the last number that you say corresponds to the number of objects in that group. As we're looking at how counting strategies emerge, there are about 5 different ways that we see counting kind of come. So emergent counters are those who can't necessarily count a collection of objects in a set. And again, what's important to point out is a lot of times the ability to count depends on configuration. So if I have a large pile of, say, beads that are randomly disorganized, a child may have problems corresponding that or counting that set if they can't create a structure for how to organize those beans. However, if it's presented in a line, a child might be able to actually do it. So it's not that necessarily that you can or you can't, but it's circumstantial and it's based off of how the objects are necessarily configured. But an emergent counter is one that cannot count a collection of objects at this time. Perceptual counters can count a collection of objects, but only if they see it. So they need to actually see, they need to be able to look at it, and then count physically based off of that. Figurative counters allow us to imagine things that we've seen and count them in our mind. So you might flash up an image of 5 objects really quickly, hide that image, and say how many were there. A figurative counter can visualize that number and say, I saw 5, here's what I saw. Counting on is the ability to count from a number other than 1. So many times when you see young children count, you'll hear them count always from 1. Can you count to 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Being able to start with, I have 3 of an object and I have 4 more of an object, to start at 3 and then say 4, 5, 6, 7 is what counting on is. Non-count by 1 counter doesn't count by ones, but not participants, but partitions, can partition sets. Let me change that. But can partition sets. I don't think that's spelled right either. So this would be decomposing or constructing, organizing this is like by 2s. Maybe you're counting by 2s or by 5s or by 10s. So that's non-count by 1s. What's really important to understand about these trajectories for counting is that 1, again, like I said, that configuration really can play a role as to whether or not children are able to engage in different types of counting. Additionally, this idea between counting from 1 and counting on a specific number is another big conceptual leap. So this is something that we can help develop and we can listen for as children engage in solving problems. So again, going back to my my beads problem, Sally has 3 beads and Joe gives her 4 more beads. How many beads does Sally have? Listening to a child count and saying 1, 2, 3, 4, 5, 6 beads versus 2, 3, 4, 5, 6 beads. They're different levels of counting. So we have to pay attention to how those students are actually engaging in that counting process. There are some great applications that we can use that have been built specifically around the research that we've been reading. One of those is Gracie and Friends. And in Gracie and Friends, there are 4 apps that are all about subitizing, so just recognizing specific quantities and matching. And then there are also 4 apps on equal sharing, which we'll get into a little bit more as we talk about partitioning, but those are about decomposing, constructing, and making sure that everyone has equal amounts. The great thing about Gracie and Friends apps is all of them have online handouts for classroom use. And actually what I'm going to do, I don't think I have video enabled here, but I want to show you just a quick little image of what these problems look like. So excuse the fact that there's no sound.
Birthday cafe.
But what you'll see is that the user of the application drags the number of corresponding kids and then looks at the food moving across the conveyor belt and matches it. And if they miss subitize, if they don't subitize correctly, it'll help show them the configuration. It'll give them a sense to count it out using their fingers, and then it'll help them match. So you can see again, in a lot of these apps, the configuration of numbers is different. And that's really important conceptually as we're developing number sense in children. The other apps that are really great are touch counts. This is a counting app that's based on adding, and it's a really tactile way that you can actually go in there and physically touch the objects that are counting. So it's a digital app that when you touch it, it actually says the number and counts. Fingu is a newer app. This is European, and it focuses on this idea of connecting fingers to numbers. So there's a lot of apps that you can explore as teachers that can help develop these early childhood concepts of counting. Going back to what we talked about last week, we had a short problem-solving session where we looked at 2 problems in class. We looked at both problems about area, but one was a fence problem with determining how much fence we could use to maximize area. The other was looking at carpeting a floor given specific dimensions. And I believe that I posted this slide at the end of class, and I want to dig in a little bit more to this idea of mathematical tasks and using them as a starting point for instruction. So first, what we know is that not all tasks are created equal. Different tasks provoke different levels and different kinds of thinking. So if you recall, the the carpeting task elicited a specific type of thinking, that being about computation of area. So we needed a way to organize the information that we had into either an array or an equation, and we could calculate the area based off of the values that were given. The fencing task required us to go a little bit further. It required us to actually think about how much fence we had, think about different configurations of fence, and it asked us to kind of generalize in what way will we have the most amount of space. So these tasks do different kinds of things when we're working with students. So with respect to these tasks, the level of the task and the type of thinking that students use to engage in solving it will ultimately determine what they learn. Okay? And Lappin and Breyer say that there's no decision that teachers make that has greater impact on student opportunities and their learning, and specifically also about what mathematics is, their perceptions about mathematics is, than the selection of tasks. Task selection is fundamental for creating opportunities to learn. It's so important to understand what a task does, what type of thinking a task elicits, and what are the possible outcomes of that task. So it's extremely important. Okay. We also know that if we want students to develop this capacity to think, reason, and problem solve, we need to start with tasks that have a high level of cognitive demand. Okay, so we're going to talk about what this is in terms of cognitive demand, and we're going to apply it to a framework that'll help us think about how we can determine a level of tasks. Okay, so the Quasar project identified tasks across 2 levels, low level and high level. And I don't want to necessarily equate low level tasks to being bad. They just don't elicit as much cognitive demand as high level tasks. They do different things, okay? So low level tasks, as they're defined, typically involve things like memorization or procedures that don't necessarily have a connection to meaning. So think about, again, that carpet task. It required us to call on a specific formula for area that we had memorized, and it forced us to apply that procedure without necessarily understanding why it works. High-level tasks involve procedures with connections to meaning, and this is more in line with doing mathematics. This is what mathematics is and how mathematics works. Okay, so we can think about this relationship through this framework. So you have tasks as they appear in curriculum. So we have a set body of tasks that are. So you can go online, you can find these, you can look in your textbooks, you can pull them out of Vanderwall or Dan Myers, but there's a specific way that the tasks are presented themselves. Then we have the tasks set up by the teacher. So this is how a teacher is able to take a task that's written and use it in one particular way, either as a high-level task or a low-level task. So how it's how it's set up. What are things that are adjusted or modified based on the needs of the specific students? Next, you have the tasks as implemented by the students. So how are the students actually engaging with the tasks? How are they treating it? What are they noticing? What are they seeing? And ultimately, this impacts the students and their learning. Okay, so in terms of looking at the task implemented by the students, that's hard to say. Factors influencing implementation are things like norms, are the teacher's disposition or their instruction, and how the students are responsive and think about and engage with the task as they learn. Those tasks that are as they're intended and set up, this aligns with things like the teacher's goal, the knowledge of math, and the knowledge of their students. So how the tasks are actually set up and structured involve aspects about what we know, our own personal belief about doing mathematics, and we link that to what students do. So we can think about these things as we're taking these problems that exist and using them with our students. Okay? Um, and these slides right here really just show what happens when we set up tasks in specific ways. So what's the learning associated, what's the retention, what's the recall when we look at doing mathematics versus not doing mathematics, which is implementing procedures. And what we see is that if we engage in implementing procedures without mathematics, there's a less of an opportunity to make connections and to learn. Whereas if we engage in implementing tasks and look at procedures with understanding, that we can lift up and better understand, better meet the needs of our students. So in looking at this kind of decline, so we see that if we facilitate tasks that are not necessarily high level, there's a chance that students don't retain, that they don't connect, and that they don't apply. So we need to think about and understand what happens when we teach procedures without understanding. And research has said we need to work on shifting this emphasis from meaning and concepts or understanding to the correctness or completeness of the answer. So we also know that providing insufficient time with students to wrestle can make students' behaviors decline. So if we don't give them enough time to solve, if we move away from this idea of meaning and understanding to just, is it correct, is it complete, these are things that can decline student performance. We know that management plays a role. So if teachers don't have a structure in place to engage in high-level cognitive activities, it can be problematic and difficult for students. We also know that it's important to select tasks that are appropriate for students. So we need to understand something about how students think and how they feel and what they know about mathematics. And we also need to hold them to a high level of accountability in terms of the process and procedures. So in thinking about how can we help students excel in solving these problems? As a teacher, we need to really think deliberately about how we scaffold student thinking and reasoning. So how do we create an environment where students can think about the problems, apply their solutions, and push forward and make connections to other student solutions. We need to provide a way for students to monitor their own progress. So we need students to be able to look and understand and check the answers that they're getting, to reason critically and think. We need to make sure that we demonstrate and model um, high-level performance. So we need to demonstrate and showcase um, productive dispositions in doing mathematics. And we need to press students to justify, explain, or think about their reasoning. We need to select appropriate tasks that build on knowledge. We need to help students by making conceptual connections, and we need to give them time to explore. So, the big picture behind this is that not all tasks are created equal. They give us different opportunities for students to learn. High level tasks are difficult to implement and carry out in a consistent way because it takes a lot of responsibility on the teacher to really push and think and not stifle, but give time. Um, but we also know that if we engage students in high cognitively demanding tasks, it leads to greater learning goals for students. And it's this idea that we need to think of ourselves as lifelong learners and that we need to understand that continuing to develop in this area, to read the research, to explore the literature and understand and engage with the community is a way that we can ensure our students are reaching their maximum potential with respect to learning. So, as we kind of move forward, if there are any questions that you have about these specific chapters or the specific studies or the specific concepts that we've cited, you can talk to Dr. Chow about those next week. You can also send me an email and I'll respond as I can. For next week, what I'm asking you to do is I'm asking you to read the first 3 chapters in the Cognitively Guided Instruction book. I'd like you to look at Vanderwall chapter 9. All of these really focus on early children's addition and subtraction strategies. Um, Ellie, Katie, I'm going to have you facilitate your Twitter discussion next week with Dr. Chow. In 2 weeks, we'll meet our case study students. And again, next week, Dr. Chow is going to be a guest lecturer for me. I would encourage you all to ask him questions, to engage with him in his work, because you have an opportunity to kind of learn and understand more about the work that he's done and his focus on teaching and learning. He's a great resource and a good person to know and to meet. So again, I thank you for listening to this. If you have any questions, please feel free to reach out and we'll see you next time.